Alright guys, welcome to RC Mojo. This week we're going to be fitting the two servos to the 3Racing X reel. To do that we're going to need bag 6. There's not a vast amount of parts in this one. We've got the radio box, some straps, the battery tray and body mounts, and well, they all look perfectly serviceable at first inspection. There's also the small parts bag, which has the usual fixings and metal bits, along with a couple of rubber bungs for the radio box. Since we're going to be needing most of the screws and bits on this page, we'll just sort them straight out onto the list to save moving them to a pot and back again. First there's the two little springs, the plain rod for the shift linkage, what 3Racing are calling a shift servo nut. It's not really a nut, but I'm not sure what else to call it. An M2.6 nylock nut, a silver ball end, 3 grub screws, 6 M3x8 countersunk screws, 2 M3x6 buttonhead screws, 6 countersunk washers, a small E-clip, and 2 collars. The rest of the small bag can get put into a pot all ready for the next page. That just leaves the plastic bits where we need the gearbox shift bar and a pair of Futaba spline servo arms. And of course, depending on your servos, you might need to use the other arms in the kit. In addition to the 3Racing bits, we also need a pair of servos. Now I got the cheapest waterproof standard size servo for the gear shift I could find, and a 20 kilogram waterproof servo for the steering. We'll start with the steering servo as it's a nice easy install, and it's also the one at the top of the page. At the front of the chassis we already have the mounts fitted. They were one of the very first things that we did. When the servo is in position, it comes extremely close to the motor terminals. Now we don't really want them touching, so we will bend the terminals a bit closer to the back of the motor, but be very careful as it wouldn't be at all difficult to snap them off, in which case we could swap to an open end bell motor, which would give us loads of clearance. Now we can offer up the servo and make sure it fits. The servo mounts from the bottom, so we need to flip the chassis over to get at all the holes. We used the 4 countersunk screws with the countersunk washers. Regular washers and screws would also work just fine, but the anodized washers do always look rather nice, even if they're brown. The 4 screws need to be done up snug, plus an extra little nip. It's another place you really don't want to over tighten them. It would be all too easy to crush the plastic lugs on the servo, which would weaken them. Now you could use a servo with an all aluminium case, but I think that's a little bit over the top for a truck like this. The servo arm needs the ball end screwing in. There's only one hole, so there's no worries about getting the wrong one. We'll probably end up swapping to an aluminium one later, but I do like to see how the kit ones hold up. Some last really well, and some strip the splines after just a couple of runs. To get the servo arm in the right position on the servo, we'll use a servo tester to make sure the servo is in its central position. Any servo tester where you can lock the center will do, or you can rig up your radio system and make sure all the trims are centered. The servo tester here is one of my designs. Sometimes it's available on 74hc.co.uk, but I've been having problems the last few months getting LCDs in any sort of quantity. I now have 400 of 4 different types that are all the wrong ones. Despite double checking with the distributor, they still sent out the wrong type. I can get the right displays, but usually they're individual or at most lots of 10, which ends up being far too expensive. Anyway, with it all centered up, we just pop on the servo arm so it's pointing straight forward, or at least as close as we can get. Install the servo screw, being careful that we use one that actually fits. Some servos use an M3 screw, and there's a few that use M2.5. Clip the linkage on the ball end, and we've got working steering. Now the geometry isn't great, but it's going to do the job. I think the main little issue is the servo arm's going to be a little bit vulnerable hanging out the front. We might have to look at some alternatives once it's all up and running. Shift servo now, which drops in quite easily. Now the linkage is going to need some careful assembly. Just like the steering servo, we use the countersunk screws and washers, but this time we only get 2. Which from a mechanical standpoint is okay. There's not going to be all that much load, but it would have been nice to have a full set of 4, just so it looked a bit tidier. The first part of the linkage to sort out is the shift servo nut. It's a steel part that slides through the end of the servo arm. I've used similar parts with model aircraft linkages, but this one is quite a bit bigger. 2-speed gearbox linkages are more often than not rather finicky to get working smoothly. So to give it the best chance, we'll add a little bit of grease so it's just that bit less likely to get hung up. And to stop it falling out, all we do is fit the nylock nut. It wants to be tight enough there's almost no detectable vertical movement, but at the same time it shouldn't cause any additional friction to the rotation. The linkage itself is just an oversized servo saver. On one end of the rod we need to fit one of the collets using a grub screw to clamp it down. Ultimately it's going to want a smear of thread lock to make sure it doesn't come loose. Next we slide on a spring, followed by the servo arm. The second spring, then the gearbox shift bar. It needs to slide up and down on the rod, so we'll add a little bit of grease just to make its life as easy as we can. The last bit on the rod is another collet and grub screw. We could move the collets inward on the rod to effectively make the servo saver action stronger, but it's going to be best to start it as loose as it'll go, with the collets right on the ends of the rod. On the square end of the gearbox shift bar, we need to partially fit the last grub screw, just a good couple of turns so it's not going to fall out. The linkage assembly can now drop down into the servo and gearbox shift rod. The hole in the gearbox shift bar slides over the gear selector rod that sticks out of the gearbox. The servo arm fits on the servo. Now we do need to make sure it's at the right angle, so we need a servo tester again. With it set to center lock, we want the servo arm to be at 90 degrees, pointing straight across the chassis, or at least as close as we can get it. The servo has plastic gears, and the screw provided by 3Racing doesn't fit. In the bag of bits that comes with the servo, there's a small self-tapper, so we'll just use that. It's always a good idea to check the size of the screw, not just the diameter, but also the length. That just leaves the grub that we fitted to the gearbox shift bar. We want to fit it so the bar is up against the E-clip on the shift rod, and then just tighten up the grub. Right on the end of the shift rod is another slot for the remaining E-clip. Now I didn't bother fitting it as it's not strictly needed, and with the quality of the small E-clips in the kit, there's a fair chance it's going to fall off anyway. That's the shift servo fitted. It's difficult to test at the moment. We can kind of see it working by turning the drive shaft, but getting the clutches to line up and spin the motor back through the gearbox isn't easy. We'll really need the motor running to see how well it works. Okay, page 20 and 21. They're more or less the same, 20 being the tray for a regular battery pack and 21 for a shorty pack. This is a really easy page of the build. All we need is 8 M3x6 countersunk screws, 2 M3x8 countersunk screws, the 2 plastic ends of the tray, the larger of the large O-rings, and I think the fiberglass tray bottom. It looks very cleanly cut, but if yours looks a bit furry, you can soak it in a few drops of cyanoacrylate and give it a light rub with some very fine sandpaper. Building the tray is just a case of screwing the ends on the outer 4 holes of the plate. One side has the countersink, so it's rather obvious which way up things go. Just watch out for over tightening, as we've got some fairly short machine screws going straight into plastic. Now all we do is line the assembly up with the 2 mounts fitted to the chassis back on page 1 and install the 2 longer countersunk screws. And there we go, job's a good one. There's just the O-ring left, which goes over the tabs on the ends. A very simple but effective battery mount. The only slight concern is as the O-ring ages, it's no doubt going to break at some point. Some sort of strap like the Traxxas TRX4 would have been better, but that would have added to the kit cost, and the price is one of the main plus points to the kit. Well, I'm going to have to leave it there for this week. A bit short maybe, but progress is progress. Next time we should get the chassis rolling and possibly get to the end of the manual. That won't be the end of the build though, there's still plenty to do. As always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a comment if you've got something to say. Bye guys!